Hi, my name is Mike North, and today I'm going to be talking about state management in Ember.js apps. So if some of you don't know me, I teach a lot of Ember developers all over the world. I like to teach people that are just learning about the framework because I think, especially if you're coming from older technology, it can be really empowering in allowing a team to get a prototype stood up in as little time as possible and really give them a great foundation to move forward with. So before I was the CTO of Levanto Financial, I was the UI architect for Yahoo's ads and data division. And my Yahoo experience combined with my consulting experience has really given me a lot of exposure to a lot of big Ember apps with lots of state management problems. And one common theme has arisen, that is that no matter how complex your app is, putting proper thought into your state management can make the difference between things being really easy to maintain and upgrades being, effortless, or having a lot of nasty bugs to fix once things reach a certain level of complexity. So what we're going to do today is first we're going to talk about techniques for identifying state. And the idea here is that if you can take a new problem and connect it to a problem you've already solved, that's a good start in terms of, how to figure out whether those same solutions apply to this new thing. We're going to do this in the context of a big example that will build up piece by piece. And today's example is going to be kind of an RSS feed app where you have articles and the ability to comment on articles. So what I've built here, what I'm starting with is it has a couple components in there, no actions at all. It's really just enough to get this stuff on the screen and the CSS, and we're going to add some first-class state management to it bit by bit. What I hope people will learn from this talk is that managing state in your Ember app, if you follow a certain framework of questions and you figure out what category of state you're dealing with, you can really make this traditionally difficult problem a lot easier and a lot more straightforward in many cases. The end result is your users are delighted, your app behaves the way it's supposed to, and this is all what we want. So in thinking about different types of state, I tried to figure out categories of state, and I kind of started by listing out all of the different state management problems I've had over the years and found 4 common themes. UI state, which pertains to presentation layer alone and often is not useful outside of the moment. Persisted state for things that have to live longer than a user's session in your single page app. Addressable state that is built around the URL. It deals with the URL and has URL related concerns. And then finally, draft state, which is a state that will be persisted, but we have to treat with care because it is usually tied to high user importance and high user effort. The forms that these 4 types of state will take in the app that we're going to build are first, the ability to filter the list of articles on the left by a little search input at the top. And you can see that we just did a hard refresh and we kept that filtering in place. So this is addressable state. The next thing we'll add is draft state, and that's the ability to start a comment on this article. And then, we can see that we have not increased the comment count on this article, which is that little number to the right side on each tile in the list. But we can see that there is draft state associated with this article. We'll deal with persisted state by taking that draft comment and sending it to an API so that all users can see it now. And then finally, we'll deal with UI state, which will involve this little panel of metadata information up at the top of the article. And we want to make sure that when we implement this, it is in alignment with what our users expect from web applications. The way our app is structured involves 2 views and 3 types of components. So we've got a posts route here with a posts/show child route. And then we've got 3 components at work here. On the left side for our list of posts, we've got this component called post tile. On the right side to render the full post, including its body transformed from Markdown to HTML, we've got this post full component. And then inside the post full component, we've got these post comment components, which is just to render the comments that have already been persisted with a little button to the right of each one that will hook up to the ability to delete it later. So let's jump in. The first thing we'll deal with is addressable state. And the core concept here is addressable state is shareable, it's historically archived, and it's all driven by the URL. So examples of this are sorting and filtering of search results or any collection of persisted records. Oftentimes that takes the form of query params in the URL. Tabs and navigation often deal with managing or changing addressable state. And then we even have concepts that are that existed long before single page apps, like the idea of an anchor tag, which will bring us to a certain position within a long document, based on an important location we might want to come back to later. So there's several ways you can identify a state that fits into this category. First, if it affects GET API calls, right? If it's an ID for a record that you need to retrieve, or if it's a perspective on persisted state, meaning something that will affect the collection of records that are returned or affect the view of a particular record that's returned, it's likely to be addressable state. Things that are built into the URL are often useful when shared with others. And if your users tell you that their back button doesn't work properly, that is usually a sign that addressable state management is broken in some way. So I want to take a moment here and talk about the contract that users have with web applications. When they come to your app, they expect it to work in a particular way. Essentially, they expect your single page app to behave like the old server-side rendered apps that we were writing in, PHP or other things, in the early 2000s. And so there are 4 examples I've picked out that we want to make sure we align with here. So the refresh button should never be destructive by surprise. So if you've filled out a long comment on GitHub issues and you accidentally, hit the refresh button, or you drag an image file into your browser, but you miss the special drop zone that will attach it somewhere, you don't want to just find yourself having lost all of your hard work. Bookmarks should always take you back to where you were, and a lot of early mobile web apps failed at this, where you'd find that you're navigating all over the app, but the URL isn't changing. And the end result is if for some reason you have to refresh, or if some reason you have to make a bookmark and you want to return there later, you really lose the ability to do all of those important things that we have to do with URLs. You can't share it with anyone, right? So this is a breach of this implicit contract between users and the web. The back button should always take you back to the previous major thing that you were doing, and that is somewhat subjective. What is a major thing versus what is a minor thing? And then finally, if you hit the back button repeatedly, you should be able to leave the app completely and to get to wherever you were before. So what we're going to do to add addressable state to our app is, again, filling in this filter input at the top of our list. And here are some of the requirements that we're aiming to hit. We want to be able to filter by a name fragment, which means the API needs to know about this, and it's going to server-side filter and give us back a different set of results. We want to be able to bookmark and share this filtered view of the collection of posts. We want to make sure that we're not abusing our API, and anytime you're repeatedly hammering on an API for results you may not care about in the end, that is API abuse. And then finally, we want to adhere to the principle of data down, actions up, meaning we want to respond to a user event and hold the context of that user event via actions and respond to that instead of responding to a change in data and using two-way data binding to pick up on, whether we need to ask for new data from our API. So the architecture or the design of the solution here that we're looking for is we're going to have a posts route, we're going to have a posts controller, and the template that is associated with that controller is going to have an input in it. When that input's key up event is fired, we're going to receive that event in an action. We're going to bind an action to that key up event, and that action will live on the controller. And then the controller is going to actually debounce before sending an action up to the route. And that route is ultimately going to just call this.refresh to grab new data from our API. That is an indication that we need to go and refetch whatever our current model is and re-render that template accordingly. Also, an important point here is in order to make sure we don't break history, when we configure this query param on the route, we're going to use this replace option, and we're going to set that equal to true. And essentially what this means is instead of the default behavior, which would add a new history state every time our query param changed, this will simply update that topmost history state. If we didn't do this, hitting the back button after you typed a couple of letters into this filter box would simply undo that typing letter by letter, and we would not be adhering to this implicit contract between users and the web. We're not taking them back to the last major thing that they were doing. So let's get started. We're going to begin in the posts.hbs template. So we'll begin by binding a search property to the value attribute of the input component and creating a queue page refresh action, binding that to the input's key up event. We'll then move on to the controller, and the first thing we're going to do in the controller is we're going to define a private function. We'll indicate that it's private with an underscore, and this function is going to send an action which will bubble up to the route, indicating that it should do something. We're then going to create this queue page refresh action on the controller, and we're going to debounce a call to this private function we just made, so that essentially we're waiting for 300 milliseconds of inactivity on this event before we will actually fire the action up to the route. So now we're going to go up to the route. The first thing we'll do here is we'll define our options for this query param. We're going to use this as option so that in the URL, our search parameter just shows up as the character S, and then use this important replace true option so we don't break our back button. The next step is to set up this page refresh action, which is very simple. All we're going to do is call this.refresh. Finally, we want to grab this query param's value in our model hook so that when we refresh, it will be called again and we can update our template. So if there's nothing interesting in this search, we'll do what we have been doing and get all posts. Otherwise, we will query for posts and pass this search name fragment along to our API. And our API just happens to work this way, so this should work. What we end up with is the ability to type something into our filter here, and you can see as we delete it and type something different, everything is working as you can expect. And if you look in the URL here, you can also see that it is updated with each keystroke, but the actual retrieval of new data adheres to the data down, actions up principle. If you're following along in the source code, here's the tag we're up to now. So things to watch out for when dealing with addressable state. The first is you don't want to trap your users. And this happens when you do a transition to in a route where hitting the back button will take you to the previous route and transition you to the forward route again, and so on and so on. You basically catch your users in a loop where no matter how many times they hit the back button, they're immediately forwarded again. So this is bad. You also want to make sure that you don't delete useful history states, and this can happen if you use the replace with method in the route hooks, right? If you're in the before model route hook and you use this dot replace with, you have to make sure that even when users are entering your app for the first time, or whether they've been in there for a while and they're transitioning through that route, that you're not going to eat a useful history state, essentially taking them 2 steps back when they hit their back button. You have to make sure you don't create unimportant history states. This would have happened if we hadn't used the replace option in our query params configuration. And then finally, there are some mutually exclusive query param options right now. Replace and refresh model cannot be used together. You have to pick one or the other. The last thing I want to point out in terms of an addressable state snag is add to home screen. So adding to home screen is essentially a bookmark in terms of how it works technically. But how users think about it is like an app installation. And so if they're on the Contact Us page of your app and they decide to add to home screen at that moment, they're going to enter your app through that URL every single time they launch it from their home screen. So you need to occasionally, do some extra work to make sure that they have the experience they expect and that it behaves as much like a mobile app as possible. The next thing we're going to look at here is draft state. At a high level, draft state is locally stored temporarily and eventually persisted. So examples of where draft state fits well are a reply to an email message, or the body of a huge comment on a GitHub issue, and even this concept of in-flight records, meaning something that you have saved to the Ember data store but have not gotten confirmation from an API that it has been persisted yet. Those are all examples of draft state. How to identify draft state? Well, first, it'll turn into persisted state. This is what makes it a draft. These things are usually associated with high user effort. They always survive transitions. And if you lose this state accidentally, it usually will be detrimental to the user experience. And that is related to the high user effort that is usually required. So here's a conceptual model that fits the scenario we're looking at here. We have this concept of a post, and we have a concept of a comment. And these two are related via a has-many relationship. We want a solution that's going to work even if we have a large number of posts. And the key thing here is that if we end up throwing a post away, we want to make sure that all draft comments are thrown away as well. So what we need here, the key tool for the job is something called a Weekmap. And if we look at the specification for a Weekmap, we can kind of extract a meaningful definition from it. So if an object that's being used as the key of a key value pair in a Weekmap, so already we're seeing that keys and values are both objects. So if that key is only reachable following a chain of references that start within that Weekmap. So what this means is if we didn't have the Weekmap, nothing would be referencing this. It would be eligible for garbage collection. So if we reach that situation, then the key value pair is automatically removed from the Weekmap. What this lets us do is essentially hold references to values without preventing those values from being garbage collected. So here is the API surface we're looking for in the official specification. We create a Weekmap, and then we can set a value on that weak map using a key object. And so in our case, we're going to want to use a draft comment object using a post as a key. So Weekmap is part of next generation JavaScript, and it is not available in all the browsers that you likely need to support. So we use a polyfill. And the hack that we use here is we actually store the value on the key. And all the Weekmap owns is a random property key, usually involving some sort of random number generation at runtime. And it is the only thing that knows that special property key that is used to access the value given a key. So if we throw the key out, the value goes with it. What I advise people use instead of using Weekmap directly is an Ember add-on called Ember State Services. This is built on top of the Weekmap polyfill and involves two concepts. First, a state factory that creates these draft state objects and sets their default values according to whatever is appropriate for your app. And then state4, which is a computed property macro that returns a particular state given a particular value. So that is retrieving a value given a key in computed property form. So how we're going to implement this in our app is we're going to add this idea of draft state to our post full component. And as we change which post we're looking at, we want to see that we're correctly updating which draft we're looking at here. If we delete a post, the draft must be deleted as well, so we don't have any memory leaks. And the Weekmap is what gives us assurance that it will be handled appropriately. So we're going to begin by looking into creating a state factory. So first, we have to create a new folder in the app directory called states. And we're going to create a new JavaScript file in there called postinfo.js. We'll import Ember, and we're going to just extend ember.object. And we have one important method to implement here. So by overriding initialized state, which receives the key that's being used for this state, whatever we return will be used as the initial value for this draft. And in this case, body is what we're going to use for a draft comment associated with a post. And we just want it to start out as an empty string. So let's move on to dealing with the post full component. And this is the component on the right side of our screen that renders the full post. So we've imported the state4 computed property macro from Ember State Services, and we're going to create a property called postinfo that will use this macro. And the first argument here is the type of state we wish to retrieve, and the second is the key under which we can find, it's the property key under which we can find the key for our Weekmap. So model is where we can find our post. And this will ensure that as we change posts under this model key, the state for computed property macro will update and it'll go and find the correct draft object to return. So next, I want to add a draft indicator to our post tile component. We're going to begin by adding a similar computed property to this post tile component using the state4 computed property macro. And then we're going to move on over to the template, and right after the author's name, if we find a non-empty value in postinfo.body, we'll just add a simple indication that we've found draft data associated with this record. What we end up with in the end is the ability to click on a post, scroll to the bottom, type in a comment, and then if we choose to click on another blog post, we should see that this comment stays with whatever we originally commented on, and we don't find it showing up associated with other records. if you're following along in the code, here's the git tag to look for. This is where we're at right now. So there is an additional thing we could do to make this even better. And that is the idea of, in the event that we find that there's draft data and we get a request to unload the window, and this could be if the user clicks a bookmark or drops a file in the window, or hits the refresh button or tries to close the tab, they'll get a prompt telling them to, confirm that they really want to lose this draft state. So there's an issue if you want to follow along the effort to add this to Ember State Services with some code that can be used, as a representation of how this might be implemented. And there's a git tag for it in this app as well. So next, let's look at persisted state. And at a high level, persisted state is just something that's stored in a long-living medium for a long time. So anything that has to live longer than your UI's session, that needs to be persisted somewhere. And so this includes anything that goes to a database or is stored to disk, anything you put in local storage or a cookie, or anything you send off to a third-party API. This is all persisted state. In terms of how we identify state that falls into this category, often it's just by looking at its lifetime. And if we need to track things over time, even if it's not of great concern to hold on to this data for a while, other than for the purpose of tracking it, you may need to persist it so that you can create a nice time series for it. Databases are often used as the source of truth and are the means by which users can kind of communicate with each other. It's the common view of the world. So a good sign that something may need to be persisted is if it needs to be seen by many users. The way we're going to add persisted state management to our app is in the event that we decide we want to post a comment, we want to see a post request go to our API. We want to see our draft state cleared in the event that this is successful. If we delete a comment, we want to see a delete call made out to our API, and we want to make sure that our solution functions even in a high latency environment. The approach we're going to take is we will wire up a delete comment action to our post comment, and then the comment should be deleted as soon as it'll be deleted from the Ember data store immediately, and then deleted from the API once that server-side process completes. If in the postful component we get an action that we want to save a comment, the comment should be saved, and then shortly thereafter, when we get confirmation that the save operation has been successful, we want to clear the draft state so we don't have that partially completed comment hanging around even after we've persisted it. So to implement this, we're going to start in the template for the postful component. And we'll begin by hooking up the delete comment action to an action that will live on the postful component. We can do this because inside the post comment component, we're consuming it as a closure action. And so this means that it can be invoked even though the action lives on the parent component, just because we've passed it in. So next, we're going to hook up another action to the onClick event of the reply button. And we're just going to call this one persist comment draft. Next, we'll go over to the JavaScript file for this component and define our delete comment action. We don't need access to the store for this. We just need access to the comment record. And we're going to use the destroy record function on this Ember data model. That will immediately destroy this record and remove it from the Ember data store. Next, we'll implement the persist draft comment function, and this one's going to get a little bit more interesting. First, we'll grab a reference to the draft comment body. So this is a string. Next, we'll grab a reference to the post that is currently being rendered in this component. And then we will invoke something we expect to be a closure action passed in passing the post as the first argument, and then that string, the comment body, as the second argument. So now we need to make sure we pass in something under save-comment. We need to pass a closure action in. So let's head over to where this component is created and wire that up. So save comment will be bound to an action that will live on this controller, the controller associated with this template, and we'll call it save comment. So now let's go to the controller and we're going to define this save comment action. And the first part is pretty clear because we have access to the store here. So we're going to call this.store.createRecord comment and then set the important attributes of this comment. I like this approach of making sure that we're creating this record as a last step rather than operating off of the created record the whole time. So after the save operation is complete, we're going to make sure we delete the draft state so we're clean again, right? So our text area is empty for this post. So to clear the draft, we're going to bring in the state4 function from Ember State Services. And we're going to use it in a way that's a little different from how we've been using it before. We're going to pass in only one argument. And what that's going to do is give us the whole week map. So we can pass in post as a key and get the post info using the public API for a week map, and then set the body attribute on this post info to an empty string. So here we're getting away with not using any controller state at all. So the end result here is that we can type a comment out, and then when we click the reply button, it will be persisted, and you can see that the post call is made to the API, and we can delete it, and we see the corresponding delete call works. So the get tag to look for here is called 3-persisted state. But I want to take this a step further. There's a common mistake I've seen in after save logic, and this has to do with asynchrony and concurrency. So if we made one small change to the way we implemented the code in this controller, and instead of passing in post as the key for our week map, we used this.getModel and reached up for controller state, we would run into a big problem. So I made this change, and I'm going to show you what happens in the event that we turn latency up to 3000 milliseconds. So we create a draft on one post, create a draft on another post. We're going to persist it, and then here's where it all goes wrong. So we can persist it and then switch to the other post. Meanwhile, the call is still in progress to the API. And when we come back, the wrong draft state will be deleted. And if we go back to the post we just created the comment for, you can see that draft state is still hanging around. So make sure that when you come back up for air after an asynchronous operation, you do not assume that application state has remained the same. And this is why when we invoked this action, when we designed it, we passed complete context around. We passed the post that we wanted to work with there, so that it's in the closure waiting for us when our async operation completes, and we can just use that safely. So here's what we look at. Here's the situation when, as originally implemented without introducing that deliberate bug. So we can create a comment here, and then we can go to the first post and create another comment. And we can see that the draft indicator will be removed from the appropriate post. So best practices for persistent state. Number one, make sure you consider that things may have changed since you began an async operation, right? When an async operation completes, you can really make a few assumptions about the state of the world when you come back. Building simple objects and then using create record as a last step is a great strategy for making sure you don't show partially created records in lists of records or in counts for the number of objects that, are in a has many relationship. You don't want to be affecting those things and kind of counting a record that is in the process of being created as if it's already, in the database. So I like to just work with simple objects, and then, as part of the code that actually, persists a record, I will create record at the last moment. Also, make sure you consider in-flight records. And here are two issues we will still run into with this app, even though we've enhanced it a little bit. Still two things we could improve. So if we double-click delete, right? If we click delete really fast, we will get an error that we've attempted to handle an event on an in-flight record. And this is because we're already in the process of deleting it. And so Ember Data is saying, I can't do anything with this because I know I'm waiting to hear back from the server, to make sure that this thing gets resolved as you originally intended. Also, if we double-click reply, because we have failed to disable this reply button, we can hit that multiple times because our draft only gets cleared when we get confirmation that our comment's been persisted. So this is where you have to be careful that you consider the actual latency your users may experience may be a lot higher than what you are working with in your dev environment. And, it doesn't hurt to kind of use Chrome dev tools to add extra latency to make sure that, things work in a way that doesn't lead users into a destructive area. So the last type of state we're going to talk about today is UI state. At a high level, this is short-lived, it's only useful in the moment, and it's only relevant to the UI. So here are some examples of UI state. Whether an accordion or a collapsible UI element is expanded or not, scroll position within a page, focus and text selection, or an indication that someone else is typing in a chat app. So you can see that sometimes these things blur the lines of one particular user, but they're always something that can almost be harmlessly discarded as a user begins a new session in your app. So how to identify these things? They're often only meaningful in the moment. They're very short-lived. They don't require much effort to recreate, and in some cases, persisting them and trying to restore that state again is going to be harmful. So imagine if you were on a newspaper's website and you reach the bottom of an article, and then you come back to read that article again, and you find that you're still at the bottom of it. That is something you'd expect to kind of have a clean slate on, for the next visit. So the way we're going to add UI state to our app is we're going to make this metadata section above our post full component collapsible. So we'll just surround the metadata with a conditional, a handlebars if helper. And in the event that the metadata is not open, we're just going to have a little span there that says details. And we're going to wire up an action to the onClick event, and that will use a combination of the action and the mute helper to set the property details open to true. And we're going to use almost the same action when you click the metadata itself, except we're going to set details open to false. In the JavaScript side of the component, we just need to add this details open property, and we're done. So what we end up with allows us to open the metadata on an individual post, but there's a problem. If we go to another post, we can see that the metadata has opened, across all posts, and that's not really what we were looking for. So I've deliberately led us down the wrong path here because I want you to remember that we have to keep the component's lifecycle in mind, and in this case, the post full component is not being torn down and recreated as we go from post to post. It's one component whose data is changing. So that state that the component owns is only one piece of state shared across all posts. So what we need to do is move that state somewhere else where it's associated with the record instead of the component that's being used to view the record. So the first thing we're going to do is get that out of the component, and we're going to leverage something we've already built here. We're going to go back to our post info state that we used for the draft state example, and we're just going to add another attribute to this draft state object. So this is already associated one-to-one with each record. So we're going to say details open is false here for the initial value. And then in the template, we're just going to take all of the references to details open and change them to postinfo.detailsopen. The end result we get now is that we can open the metadata for one post, and it only stays open for that one post. So on a post by post basis, we have some UI state hanging around. Here's the get tag to look at for this stage of the app. So in terms of what we've covered, there are 4 different categories of state. And if you can identify whether the state you're struggling with in your Ember app is in one of these 4 categories, you can start to think about what approaches apply broadly to these categories as a whole. It's useful to think of other ways of distinguishing between these categories of state so that you can more easily find where a given state challenge belongs. One way is how far away the impact of a state change is felt. So UI state is often very local, very close to that state change transition is only felt, within a particular view or within a component. Draft state only affects one user's session, and then addressable state and persisted state can have effects that are much more broad. In fact, we may want to consider that persisted state is often closely related or a subset of addressable state, because often you need cues from addressable state in order to go and retrieve the correct persisted state. We can also think about these categories in terms of who it affects. So often UI state and draft state affect an individual user, whereas addressable and persisted state are potentially affecting the whole system, your whole world. We can think of these different categories in terms of user effort that's required. UI state only requiring a couple clicks, whereas draft state being reserved for something that requires high user effort. We can think of them in terms of the lifetime of that state. UI state and draft state are both short, and addressable state is much longer than a session, potentially as long as your system lives. So in conclusion, I hope I've convinced you that good state management matters, and that if you identify it and tame it, you're going to delight your users. Thank you very much.